All right, coming back at you. This is Coach William Polite out here in Wichita, Kansas. Guys, going through some of our math packets. This is our seventh grade math packet, the first part of it from week 2. You can download these at usd259.org and just go on to our continuous learning, and you can just download them and print them out or do them right there on your computer. I'm just offering a few examples from this packet. I've got a few calls about this proportional relationships between from graphs and from tables. So we're going to go through some examples here real quick. And as always, we're praying for all of our families across the country through this coronavirus pandemic, guys. We're going to get through this, and I know we are. So, but let's try to get through a little math here. This first part here, as you can see, is proportional relationships from graphs. And what we're looking at here is to looking at you can see the example here is looking at when a graph has a straight line that passes through the origin, which is here 0 0, and it's a straight line that will represent a proportional relationship. Okay, and then we're going to find this term here, this constant of proportionality. That's also called a slope or rate of change, when we put our y over x, or the change in y over the change in x. And you can see here, like this one went up 1 and over 4, and that's why they had this slope or constant proportionality as 1/4. I've got an example that I have started on here with the first one. And so this was the line, the blue line they gave us. And then I put in the red here. So I went to the 0.42 here. And then I went to the 0.84. And then I went to the 0.12.6. And you can see it's going up 2 over 4, up 2 over 4. Okay. And so that's why we have our y. Oh, this should say actually over here, that should say x over y, y over x. Okay, yeah, so that should say y over x. I got that changed for you because our y is 2, in this case, the 0.42, and you can see the 0.84, that's x on the bottom, 0.126, and we break that down, and that's 1/2, our constant proportionality. It's a tongue twister. And so this number 2, now this would not be proportional. Why? Because it doesn't go through 0 0. Okay, so that, remember, it has to go through 0 0, and it has to have a constant rate of change. Sorry about that. So like this one here, this is not a straight line. Okay, here we have a straight line going through 0 0, so it would be proportional. Okay, this one would not be over here. Okay, and you can look at the rest of those too. You can see that doesn't go through 0 0, nor is it a straight line. This one does. So you need to find the rate of change and graph some points on there and find out what that constant proportionality is, as we're calling it here. Both of these, I think these are the same problem actually here. It's a misprint. But you can still see that that goes through 0 0, and it's a straight line. So you should be able to find that constant of proportionality. Now we're going to look at plot the points from these tables on the coordinate plane. Okay. If the graph represents a proportional relationship, determine the constant of proportionality. So now we're going to take a table here, and we're going to plot the points. So I've already done that for you. Let me see if I can make my headshot a little smaller there. There we go. Okay. Now you can see here the point 16, 20. Let's see if I can go up a little bit here. See here. Oh, sorry. Okay. You can see the point 16, 20 here. Sorry about the delay there. Still learning this technology, folks. There we go. There we go. Okay. So I plotted the point 16, 20 And then this point here, 2430. So we come over here to 2430, 32, 40, and 36.45. I plotted those points, okay, and then I drew the straight line there. And you see it comes down through 0, 0. And then we come over here and I put my y over x for each one of those points. And when you break those down or simplify those fractions, they all equal 5/4. So the constant of proportionality uh, or the slope there is 5/4. Okay, so pretty easy stuff. Constant of proportionality. It's a tongue twister, but hey, no big deal for you guys. Now let's go down. Let's keep going here, and you can come over here and do the same thing with this table. And I think all of these will be proportional. I've checked a few of them. So you plot the points and then figure out your constant of proportionality like I did in that first example. Now we're going to come down here. Oh, I did another one here for you. Um, Hours spent tutoring and the dollars charged. Okay. And so here you can see we had the points. Oh, see if we can get it back down a little bit. There we go. 10, 24. Okay. And then the points 25, 60. And then the points 35, 84. And you can see that I drew the line there. And then right below that, I put those into y over x. Each one of those points, put the y over the x. And then we broke those down and simplified it. And that's 12/5, which is our constant of proportionality. Okay. That's two examples there for you. Okay. And guys, even though this says seventh grade math, this is stuff you'll do all the way through high school and even into college. So it's good for everyone to review these. Okay. Now here's one where we're going to take a word problem and make an equation out of it and figure out the constant of proportionality. Okay. So like this first one here, it says during your morning workout, you run for 20 seconds for every 3 seconds you sprint. So we're going to let x equal the seconds that you run and let our y equal the seconds that we sprint. Okay. So if I put y over x, that would be 3/20. Now it wants us to also make this into an equation. Well, that would just be moving my x over here to put that into slope intercept form, basically. And you can see we did that here. So y is equal to 320x, 3/20 x, okay, or 3/20. Sorry, my tongue's getting twisted there. Need some water. So hopefully that is helpful for you. And I think we got one more hit. All those are pretty easy, guys. You do the same thing I did on number one with all of those, okay. And then let's go down here to um, this table here, okay, and we're going to jump right in and looking at completing the table and then drawing a graph from that completion. Okay, so it's telling me that she noticed, Jessica, she's been many days at the city park last summer. She noticed that 4 out of every 15 flying insects she saw at the park were butterflies. Okay, so for every 15 insects, there were 4 butterflies. So if I take 30 insects, that would double that and make that 8 butterflies. If I had 45 insects, how many would I have there? Well, that would go up again proportionally, and that would be 12 because we would add 4 to that, right? Okay, not double. It goes up by 4. I'm sorry, I shouldn't have said that. Shouldn't have said double. It did happen to double in that case. So what if I put another 15 on there? Okay, well, for every 15 butterflies, we have 4, so that would make this 16 now. Okay, see what we're doing? Okay, so what would happen if I got to 75? Okay, if I had 75 butterflies, well, you just go up another 4. So we're increasing 4 for every 15 butterflies. Okay, so for every 15 insects, and that gave us 20. Okay, so if we were to come down here now to see if we can actually graph this, And I've already put the numbers on this graph. You'll have to number your graphs. And we said for every 15, let's see if I can get my tool going here. Okay. So we'd be at 15 and 4 here. Okay. And then we said 30, we were going to be at 8, right? Okay. We'd have 8 butterflies. If we had 45 insects, we'd come here to 12. If we had 60, we'd come here to 16 butterflies. And if we had 75, we said we would have 20 butterflies. Okay. And we can see, wow, looky there. Got a nice straight line that's going to come out of that as well. Okay. And let me see if I can get my line figure going there. And let's see what happens. If I have that drawn right. Yep. And so you do have a nice straight line there. And mine's a little off from 0 because of where I started there, but it still comes pretty close there. Okay. Yeah, we're there. All right. Good deal. So that's stretching our thinking a little bit there. And so I hope that's helpful for you. Constant of proportionality. There's some other problems in that package for you to work as well. USD259.org to download. God bless, and everyone stay safe and stay home.